Welcome everyone to today's webinar, The Preferred Way to Keep Your Facility and Equipment Safe from Cybersecurity Threats. I am Michael Sipes and am joined by Luke Amory, who will be giving the presentation. Luke Amory has been with Preferred for over 4 years and has a background experience in OEM controls and IT engineering. Luke Amory heads up the Preferred Cloud team here at Preferred. Thank you for speaking with us today, Luke.
All right, thank you for that introduction, Michael. My name is Luke Amory. I'm going to be the presenter today for the cybersecurity webinar here at Preferred Utilities. Thank you all for coming out to join us. I really appreciate the interest in this topic. It's one that I'm deeply passionate about, and I hope I can share a little bit of that with you all today. So just to get started, this webinar is for if you're a facility owner or manager, engineer, designer, service technician, or contractor. This is all going to be relevant for you. Security is a shared responsibility amongst many stakeholders, and it's important that all participants in the decision-making process for how equipment's installed, maintained, and used are at least aware of the cybersecurity risks and potential threats that exist for equipment that's installed and operating at your facilities. There's just 3 main things that I want you to take away from this webinar today, and that is that cybersecurity risks are becoming more prevalent every day. Just as the world is becoming more connected and we rely on these computerized services and pieces of equipment more often, there's inherent risks that increase with that, and just being aware of that will give you a much better posture when it comes to mitigating and preventing these risks. And in that same thread, as these connections develop and environments change, these risks develop and evolve continuously, which essentially, as things become more connected and or connections change, different people are now interacting with different pieces of equipment or services. Risks can change over time. They can reduce or, in most cases, increase in the amount of harm or potential harm that's available for an attacker to cause. And then again, mitigating these security risks is not a product that you can buy or a service you can subscribe to. It's a way of life, and it needs to permeate your culture of both your team and your company, and really it needs to be taken into consideration at every step in most processes, and that is ensuring that there's both security as things are being developed and as they change and evolve over time. As these decisions get made, it's important to always keep security in the back of your mind. So as I'm sure most of you are aware, that we see these cybersecurity threats perpetrated every day. It seems like every week we hear about new ransomware attacks at schools in Texas and in Florida, city governments compromised, outages lasting weeks. A few of them that stood out to me are in 2019, in May, we saw Norsk Hydro, a world leader in aluminum production. They had a global outage as the result of an attack on their infrastructure that ended up costing them over $52 million, halting their production for several days as IT teams attempted to repair the damage that was done by this attack. And then in the same thread, more recently we saw the DMANT attacks, where they're one of the largest hearing aid manufacturers, and with that attack we saw an outage of almost 3 weeks in some cases, where people were unable to book appointments for having their hearing aids calibrated and other things that resulted in over $95 million in lost sales for the company. And then over the summer, we saw a vulnerability that came up in an embedded piece of software called VxWorks, which is in pretty much everything from your pacemaker to the software that's running on the Mars rover. Really critical pieces of infrastructure all running on this software that has severe vulnerabilities that can be exploited very easily. And then a little bit further back, but I wanted to highlight it because of its impacts on cyber warfare. In Ukraine in 2015, we saw a power station there attacked by a foreign adversary that resulted in 230,000 people without power for hours, completely disabling all of their SCADA systems and causing the power service provider to have to send out units to substations to reactivate service to their customers. So to get started with the meat of the webinar here, I just wanted to just clarify that there's a lot of content out there for cybersecurity in general, a lot of it pertaining to cybersecurity in the enterprise and cybersecurity for data systems or credit card processing. But what I wanted to focus on here with this webinar was cybersecurity for facilities, both commercial and industrial, and the equipment that exists in those facilities. That can potentially be compromised. We see threats to these facilities and equipment growing every day, and I believe it's going to be a topic for the next few years as far as securing these assets and being able to monitor and ensure that there's no attacks taking place. To get started, if there's one thing that you need to focus on for this segment, it's that a risk exists when an asset is vulnerable to a threat. And you can see here on the Venn diagram that the risk is at the intersection of the threat, vulnerability, and asset. Where all three of those things exist, you have a risk. That risk can be small, it can be large, but anytime you have those three components, it's a risk. So the first part there, the asset, traditionally you think about this as something that requires great capital expense or something that's expensive to repair or replace in the result of damages or something like that. And then also more focused on our topic for today, the things that are required for your facility operations or for regulatory purposes. So things like boiler systems, emergency generators, these things are what keep your facility up and running, and if there was an outage or downtime for some reason, it would cost you money. And keep in mind that assets can not only be things that are valuable to you, but they can also be things that are valuable to an attacker. And the two categories that attackers normally look for are devices that can physically or electronically control physical objects in their environment, and devices that control large amounts of energy or potential energy. So when we're thinking about devices that handle fuel oil products or natural gas, these are devices that are potential targets for an attacker. So when we talk about the next component here, which is vulnerabilities, the definition of which is a flaw that it can be leveraged that will result in unintended behavior. With this topic in particular, you can really get into the weeds as far as the specifics of each vulnerability, but for the purposes of the webinar, I've simplified this into pretty much three different categories, and that would be physical vulnerabilities, internal vulnerabilities that can occur on your network, and then external vulnerabilities that can be exploited over the internet. And so just as an example to help you visualize, so for example, let's say that you have a pump, and the pump can be controlled by an operator at your facility. He can increase or decrease the speed depending on the requirements of the system. A physical vulnerability for that pump would be if somebody was able to physically interact with it and cause the pump to change speed or to come out of service, which would be if they were to take an axe to the power line, or they were able to damage the pump in some way that caused it to no longer function. That would be considered a physical vulnerability. If that pump was attached to a control system and it could be controlled within the network, maybe via a SCADA system, and potentially an attacker on the network who has maybe already compromised another device on the network could potentially use that interface that the SCADA system uses, bypassing any controls that exist on there, to change the speed of that pump, or prevent the SCADA system from communicating with the pump, or disable the pump entirely. And that would be considered an internal vulnerability, something that can be exploited just on your internal network, but you don't need to be physically close to the pump. And then again, along that same thread, an external vulnerability is pretty much the same thing, except that it can be exploited over an internet-connected network. So if your SCADA system has an interface to the internet, a potential vulnerability can exist between your SCADA system and the pump that would allow for a remote attacker to either damage or modify the pump operation in some way. And so again, just to summarize again, a vulnerability is a flaw that can be leveraged that will result in unintended behavior. These vulnerabilities can be very minor, or they can be very serious and have large consequences and cause lots of damage if exploited properly. So the next component here of our risk would be a threat. And a threat, in most cases, consists of two parts. You have a threat incentive and a threat actor. And incentives can range anywhere from mischief to physical damage of equipment, damage of your operation or the services that you provide to your customers or your inhabitants of your facility. And then reputational damage. If somebody is able to access your systems and very publicly disclose that they did so, that can damage your bottom line and reduce public trust in your facility or your enterprise. But probably the most common threat incentive would be data theft, manipulation, and ransom. And what that most commonly looks like is somebody operates some public-facing web service or internal database of either employees or customers. That information is a valuable asset for an attacker. They want that information because they're able to sell it, or they're able to encrypt it and then charge you a ransom in order to decrypt it so that you can access it again. That's what we've most commonly seen at public municipalities in recent months, is that attackers will ransom all of the data on a municipality system, whether it be their billing system for their water utility system, or in the case of a school, their student records. They will encrypt that data and then charge the owner of that data a ransom in order to decrypt it. And then the other final part here of what can incentivize a threat can be your access to other networking or compute resources. If you're known to have a lot of computers or a lot of powerful computers, an attacker can potentially leverage that to do what is known as mining cryptocurrency, where they use your computer's resources to create hashes that result in cryptocurrency for their benefit. And then just to summarize the different actors that can potentially perpetrate or are incentivized by these incentives, by far the most common is automated systems that are developed by cyber criminal professionals that develop automated systems that scan the internet looking for vulnerabilities, trying to either create a botnet or to perpetrate DDoS attacks, or like I said, mining cryptocurrency. That's probably the most common threat actor that you'll see is an automated system like that. And usually targeted attacks are pretty rare as of right now, and we're really only seeing those in public municipalities and other more public-facing places. But of course, there still exist threat actors that can be a disgruntled employee, or organized crime, or activists that want to harm your facility or corporation in some way. And then, of course, especially with that Ukrainian power outage, there can be cyber warfare going on from nation states. So really, you can draw threats in from many different places, but it's good to know what exists out there and how, whether or not you should be worried about each of those. So just to summarize again, and I'm going to come back to that definition again, is a risk exists when an asset is vulnerable to a threat. So just putting all of that together, let's say we have an asset, which would be, we'll come back to our pump example, that is required for circulating hot water in a facility. And then we combine that with a vulnerability in the software that runs the pump that's internet connected, that allows a potential attacker that's incentivized by damaging your organization or your facility operations to disable or damage your pump in a way that is a risk to your facility or your enterprise. So now that we've talked about what a cybersecurity risk is, we're going to talk about how they develop and why they're becoming a little bit more commonplace in this day and age. And by far the first most common reason that these risks develop and they are becoming more common is that as the need for automation and more control over processes that we rely upon to heat our buildings and make our cars run more efficiently, we are controlling things that used to be a completely mechanical or physical process with control mechanisms that require electronics or a computer to operate. A great example of that is the carburetor in your car. It's probably been a while since one of us has driven a car with a carburetor, but what used to happen is that the carburetor was responsible for mixing your fuel and air before it entered the cylinder. And the way it did that is by when air was forced into the carburetor, it created suction which pulled more fuel into the carburetor and therefore into the cylinder to be combusted. Now, because of increased regulations for making things more efficient and reducing emissions, using a carburetor is not precise enough to be able to operate in a modern vehicle. So now we have these complicated fuel injection systems that have fuel pumps and injectors with valves, and all of these systems are controlled by a computer or a piece of electronics that it can potentially be compromised in some way. That physical process that existed before, there was no way to interact with it other than physically touching it. But now that we have these electronic systems, potentially someone can rewrite the firmware on the controller or modify or send the system some signals in a way that prevents it from operating correctly. And we're seeing this across industries. I gave the example of the car, but with boiler systems, we now see that they have O2 trim. With generator systems, we have electronic starters and monitoring systems that check those batteries. And all of these systems, as they become more computerized and digitized, they become a little bit more vulnerable to attacks. So the next components that contribute to why we're starting to see these risks develop more often and become more serious is that devices that were traditionally not connected are becoming connected. In the example that I have here, we have a facility that has some fuel oil tanks, emergency generators, some boilers, and then some operators that run around all day monitoring each piece of equipment and going from place to place, checking on the status of it and moving from boiler to fuel oil tank to emergency generator. But what we often see happening is facilities, in order to reduce resource costs, they're installing SCADA systems, which they're connecting up existing pieces of equipment to these SCADA systems so that they can be centrally monitored from one location or by fewer people. And then the pieces of equipment themselves will, as these control networks become more prevalent, they're getting rid of physical interfaces to, for example, to command a pump to start or for a fan to run, and they're starting to, these devices are starting to communicate over these networks and rely upon these networks in order to operate. But what will most commonly happen is that when this control room network or SCADA system is implemented, is that there will be very little consideration for the security of the interfaces that exist for that existing equipment. And what you'll see happening is that the equipment interfaces are being used in ways that they were never designed to be used, being accessed over the network and modified to run remotely with an interface from the SCADA system. And that leaves a facility very vulnerable to attack. If an attacker is able to access that network in some way, they can potentially, especially if you're using a Modbus TCP, which requires no authentication or authorization in order to modify or read points. An attacker, just by being on the network, has the ability to modify the operations of your systems or even potentially disable your systems from operating in the way you intend. And what we're seeing in most recent years is that organizations have a need to, as these systems become more complex, you want to involve the OEM anytime that there's a problem with the equipment. Because of that complexity, there's so much that can go wrong and so many different diagnostic codes that it can be confusing for your everyday operator. And so what we're often seeing is remote interfaces created for OEMs of equipment, which are now, you're exposing your control room network, which it has its own flaws, to the internet, and creating a very dangerous situation. The best example of this going wrong that I can give is the Target breach. All of those credit cards that were stolen, millions of credit cards, millions of transactions recorded, that was perpetrated through an attacker that compromised a mechanical contractor for Target that had a remote interface to monitor the refrigeration systems remotely. And once the attacker was able to compromise that mechanical contractor, they were able to get a foothold in every single Target building in the world. And that allowed them to record credit card information and then sell it or use it for their own purposes. And so the other major vulnerability that exists with these classic or legacy control systems is that often this is new territory for these OEMs that are developing this equipment. And especially, I touched on that VxWorks vulnerability earlier in those embedded devices in the Mars rover and in your pacemaker. That software is also used in industrial controls. And what we've often seen with those is that they have no mechanism to be remotely updated. And that can be good because that means an attacker can't update the firmware, but in this case it's very bad because the OEM is not able to update and patch these vulnerabilities that are known to exist and that are actively being exploited in the wild. And that just, we've seen that in the IT community as well, and we've largely gotten away from it now because these OEMs have learned over time that it's important to continue to support products after you deploy them in the field, and they also develop service contracts for those products. But oftentimes with the industrial control products, they deliver the physical good, and then that's the last time they have a relationship with the facility or the corporation. And what you see is that we have these vulnerabilities now that are known. Attackers know about them. Hopefully you know about them. And even the OEM knows about them, but there's no mechanism in place for them to patch them. There's no way to mitigate that risk that exists in your control room today. And the other reason that we're starting to see these attacks become more commonplace, it's less relevant for the industrial and commercial industry, but more so for the municipality and the enterprise where they have lots of users interacting with their systems on a regular basis, is that we've seen the rise of cryptocurrency, which is essentially a form of currency that can be transmitted over the internet without a paper trail. So a government is not able to investigate where the money is going or coming from, and therefore an attacker can compromise a system and then demand a ransom for reestablishing that system for the victim of that crime. And the victim is forced to pay that ransom, and there's no way to track where that money is going. And so we've seen this increase in criminal activity in this area because it's more easy to get paid by perpetrating these attacks. And then also in that same thread, you'll see when public-facing internet sites or other services are compromised, what will most often be the case is that an attacker will install what's called a crypto miner, where they're able to use the computer's resources to generate that cryptocurrency and have a good payday. So now that we've talked about what a risk is and why they're becoming more commonplace, I want to go over with you an example risk analysis, what you would go through if you wanted to analyze some existing risks that are in place at your facility. For this example, because preferred utilities, boilers are our bread and butter, I'm going to use a boiler. But it's also very common for a boiler to be an incredibly valuable asset both to you and to an attacker, but potentially not always viewed as a valuable asset. In the event of a boiler outage, you can sometimes be required to find alternative housing for your residents, or be required to close your facility, prevent if you lose heat to your facility, you can no longer house patients or residents. The costs of a boiler outage or heat outage can sometimes be far greater than just the repair or the replacement of the equipment that's actually broken. And that's one of the reasons why I chose it for this analysis. And then the other reason is that to an attacker, a boiler is a great asset because it has a high energy potential. There's lots of moving parts. It has access to a tremendous amount of combustible gas or fluid, and it can be potentially used in a very dangerous manner that causes a lot more external damage than could be committed on something like an emergency generator. So to start with the risk analysis, the first thing that we're just going to do a very simple analysis for physical threats. So when we're looking at our boiler controls, you can see that's in the center of the circle here. The first line of defense for those controls are your application security features. And with the boiler control system, that's going to be something like your operating limits, your high steam pressure switch, your high water temperature switch, your low water level switch, all of these interlocks that will physically prevent the system from operating in the event that one of these switches is not working or it is in a trip condition. And then the next component of that is input validation. So whenever the system receives input, whether it be from an external source or from an operator, that input is validated to make sure that it's within the range of the capabilities of the system and that the system is able to accept and calculate that input to an operating parameter that makes sense for that environment. And then most commonly you can have functional access controls. So you'll see that certain features of modifying the way the boiler operates, adjusting combustion curves, or changing parameters on how the boiler responds to a firing rate increase. Those are all only permitted to users that are able to enter in a password that asserts that they have the correct knowledge and skills to be able to modify those parameters safely. So again, all of these features that exist here for this application level are those that exist inherently in the boiler controls. And the example that I used here is our burner mate universal that we sell here at Preferred Utilities. It's a system that has been validated to be very secure against both internal and external attacks. It has a very good logic system and safety system that prevent against unsafe operation of the boiler controls. So the next part of the controls security would be the device security level. And what this includes are the functional access controls that prevent a malicious piece of code from modifying other parts of the system or operating with outside of the normal bounds of a piece of software. And the user access codes, which along the same lines prevent a user from operating with beyond their bounds or performing functions that user doesn't have permission for. And then again with the BMU, we've taken care to make sure that when a piece of firmware is loaded onto the device, that the firmware is validated to make sure that it matches what is expected for the device, so that if an attacker is somehow able to get a hold of a firmware image and then physically interact with the device, that they would be unable to load a modified piece of firmware without having it validated by Preferred Utilities first. And then with the BMU in particular, we have a network of pre-authorized technicians that are able to securely access these devices without creating a backdoor system. Each user is able to generate their passwords on a per device basis and prevents a widespread vulnerability of the same password on every device from being exploited. So after we have application and device security, the next level is physical security. And again, we're still talking about components of the actual physical control system that's usually provided by the manufacturer. And in the case of the BMU system, or pretty much any of the control systems that we provide, those include locks on the enclosure doors to prevent unauthorized access to the control system, and then protections in place for the interface. It's difficult in most cases to be able to access the programming interface for our controllers and be able to modify that in some way. And with physical security, this is the first level where the security of the system becomes a shared responsibility. So with the previous levels, all of those security features were embedded to the device itself. But now with physical security, it's a shared responsibility between the equipment manufacturer and the facility that uses that piece of equipment for their operations. And I touched on the part that the manufacturer is responsible for, but what the facility is responsible for is making sure that there are access controls in place, which can be just as simple as having locks to the doors to access the control room or the plant where these devices are being used, and then a system for identifying personnel and being able to quickly identify people who don't belong in a certain area, and then other measures to make sure that any bad actors that would like to cause mischief or other things, that there's deterrence components or surveillance components that allow the facility to prevent those kind of actions. So now that we've gone through the barriers that are in place for the physical threats for our control system, now let's take a look in the event that we connect this control system to a network. What are the barriers in place to prevent an internal threat from exploiting a vulnerability in our system? So with the first layer here, we're still talking about application security, and it's going to be the same for physical and internal threats, or really all threats for that matter, because these are inherent pieces of the control system that prevent unsafe functionality of the system. So I'm not going to go over this again, but just keep in mind that this component, the application security, is common to preventing all threats to this system. And then the next part here is where we start to diverge. So the physical threats rely on device security characteristics, and now the internal threats, the features that we rely upon, most commonly in the IT world we call those endpoint security features, but I understand that term is probably not common in most circles outside of IT there. But with that being said, the two additions that we now have for preventing unauthorized access on an internal network would be that when a BMU control system is connected to a touchscreen or some other interface that has a network connection, there's a client whitelist of IP addresses that are allowed to access the device. And when those IP addresses do access the device, there's a firewall in place that prevents other nodes on the network from unauthorized access to the device itself. And so now that we have the next layer here, which is going to be on the physical security side, we've already talked about this, and you can see that there's the shared part there in red and the part there in blue, which represents the equipment manufacturer. When we come to the plant network security, though, that's entirely on the facility. Devices or endpoints on the network have very little control over the traffic that is going over the network. They can only prevent traffic from communicating with themselves. So that's why it's the responsibility of the facility. Some best practices and examples that I have here are segmenting your network. In the example of the Target breach, if they had just segmented their credit card processing systems from their mechanical or refrigeration systems, that would have never been a problem. They wouldn't have been able to get the credit card information because the network would have been segmented, and there would have been controls in place that would have prevented traffic from traversing the network, going from the refrigeration system to the credit card processing system. That's a very simple control that you can put in that will prevent a lot of exploits from being used by an attacker. And then next, along that same line of segmentation, access control. So if there is a need for traffic to traverse segments of the network, make sure that you have access controls in place, that the entities or the users that are able to traverse the network, that they're authenticated before they're able to do that, which would prevent an outside attacker who gains access to one part of your network from moving to another. And then along the same lines, and more sophisticated systems, you can do what's called microsegmentation, where every single endpoint, every node is on its own segment, and all of the traffic in and out of that node is able to be segmented on its own and validated to make sure that it is authentic and that it is allowed on the network. And then to monitor all of these systems, commonly you'll see an enterprise with an intrusion detection or an intrusion prevention system in place that monitors the network for anomalies and things that seem out of place, something that would be very difficult for a human to recognize quickly. So now that we've analyzed the threats that are coming from the physical vector and the internal vector, between internal and external, there's only one additional layer of protection that you have there, and that's your perimeter security. Most commonly, that's a perimeter firewall, content filtering for the traffic that's egressing or ingressing your system, and then honeypots that are able to, when somebody does infiltrate your network, you create a fake asset that looks valuable but will immediately notify you anytime someone tries to access it, which would be an indication of an intrusion to your network. And again, just like we talked about on the internal side, doing packet inspection and just monitoring for abnormalities is a key part in any network security. And now that we've gone through each of the three threat types that I talked about, the physical, internal, and external, as you can see here on the image, we've now enumerated all of the different security features that are in place that prevent a compromise of our control system. That being said, there can still be a vulnerability in one of these features, but because of this defense in depth model that we've used here, usually you're pretty secure unless it's a very targeted attack. But just by being aware and looking at the controls that you have in place for protecting against attacks from different vectors, you're able to better have an idea when you see in the news that there's a vulnerability with VxWorks, or you see that there's a problem with the Linux TCP/IP stack. You're able to identify, oh, that is a vulnerability in the physical or the software layer on my device, and I need to get that patched because I only have one more layer of security above that, and it could potentially allow an internal and external attacker to compromise my systems. And of course, this system for identifying all of these security features, it's great to do on your most valuable assets, but it's also a good idea to do it on some of your the assets that you don't always think about all the time. If you have internet connected thermostats or other things, these are devices that can commonly be used as a foothold for an attacker in a network. If that device is somehow checking out to the internet to get firmware updates that it doesn't validate, potentially an attacker can rewrite the firmware on the device remotely and then get a foothold in your network in a place that you didn't expect. And so it's good to do this analysis on a regular basis, and also just when you do find out about a vulnerability, come up with a plan to mitigate that risk and be able to defend your system. So if you're looking at these security controls and getting a little overwhelmed, I don't blame you. This is a lot. Even for enterprise organizations, they invest a lot of money and time in doing these analyses and ensuring that their equipment is safe. Recognizing this problem of investing this many resources in defending your assets, but still wanting to get the benefits of remote connectivity, Preferred Utilities has developed a product that helps small and medium businesses and facilities connect their equipment to remote monitoring solutions without exposing themselves to additional risk, and having that risk managed by Preferred Utilities instead of having to manage that on their own. So by installing one of our network gateways at your facility, what you're essentially doing is you are taking the responsibility of managing those external threats and the security features that prevent against those threats, and you're putting that off onto the Preferred Utilities. And what we do is by installing the gateway, you're connecting that piece of equipment to our private network, which operates outside of the public internet, and is removed from access by any adversaries. The equipment is only able to communicate with our back-end services that collect data and use that data for things like data analytics, dashboards for equipment that can be monitored remotely, and notifications and alerts whenever there's a problem with your equipment.
All right, that summarizes all of the content that I was going to talk about today with the webinar. I hope that you all were able to get something out of it. And if you're interested in learning more about doing threat analysis or interested in the Preferred Cloud platform, you can go to our website, preferred-mfg.com, and get in touch with one of our applications engineers to get you started on getting your facility more secure or starting a new remote monitoring project for your equipment. At this point, if you have any questions, I'm going to be going through them now and answering them. I have a few here to start off, but there's still time to get your question in if you haven't already. All right, and it looks like, so the first question here is, what other communication protocols do you recommend besides Modbus? So yeah, in the webinar I mentioned that Modbus by design is inherently insecure. It evolved from a protocol that was only designed to be used over a serial connection, and when network connections became more commonplace, we started to see vendors coming out with Modbus TCP, which is essentially extending that serial protocol that was only designed to exist over a single physical interface to now it exists on a network. And when they did that, they didn't add any additional controls to it. So you saw you have no way of authorizing or authenticating whether or not when you write to a point, if that point is valid, or there's no access controls for controlling who can access what points. And other than doing network level whitelists and blacklists, there's not really much controls in there. So some alternatives to Modbus TCP would be systems like BACnet, which is very common, or OPC. That being said, those protocols, they can be configured to be set up securely, but it's very easy for them to be set up insecurely. They both support methods of communications that do not require any authentication or authorization, and in some cases are just as insecure as Modbus TCP. So when you do use those protocols, either OPC or BACnet, it's important to make sure that whoever's installing those controls, that they have a good background in setting those up in secure environments and being able to validate and monitor to make sure that the communication protocols are being used as intended. Okay, and then the next question here is, does the preferred cloud platform work for more than just PUMC equipment? So the short answer is yes, it does. The platform is completely customizable, so we can add in other types of equipment, emergency generators, air handlers, all the things like that. But you'll definitely get the best user experience and the first class user experiences with preferred utilities equipment, just because we have resources in house that are a lot more familiar with that equipment, and therefore we're able to leverage more features on those products. All right, and I think those are the only questions. If anybody else would like to ask a question, now's the time. All right, so it looks like that was it. I thank you all for joining us. I hope that you are able to get something out of the webinar, and it's going to make you and your facilities a little bit more secure in the future.
All right, thank you all for coming. I really appreciate it. Once again, thank you, Luke, for coming. And that's it for the webinar. We will be posting the webinar video recording, which you can watch later. You can log on to that through the webinar app. You can just, the same exact link, or a link will be sent to you just like the link that was sent to you for this webinar. And you can click on that and watch the webinar again. If you have any questions for Luke that might come up with your facility, just feel free to try to get a hold of him or one of our expert technicians here. Thank you very much. Have a great day.